Welcome to the Radcliffe Institute for Advanced Study. It's nice to see a wonderful turnout for the Dean's Lecture here. So perhaps remind you or tell you, the Radcliffe Institute is primarily a multidisciplinary institute that knits together the arts, humanities, sciences, and social sciences. We have a fellowship program. We have a program on science symposia. There's a gender conference coming up on gender and violence on April 9th and 10th. My name is John Huth. So let me introduce our speaker for today, David Montgomery. He is a professor at the University of Washington and heads a geomorphology group, is also a MacArthur Fellow, the author of 3 books and another book that is forthcoming. And we've had, I don't know, somewhat similar interests in kind of the way science develops in a not so straight and narrow path as sometimes we're taught. And so this appeals to me greatly. Geomorphology, for those of you who don't know, is the study of how the topography of Earth's surface is influenced by events like earthquakes and floods. And in fact, the issue of the flood and the Noah story is the topic of today's story. I should mention on a personal note, I always like to throw in a personal note, is a few years back I was doing a backpacking trip in eastern Washington state. And as I was driving to do this backpacking trip, we were traveling through this strange landscape, and I had no idea what on earth was happening with this landscape because it looked weird, something I'd never seen before, and I was just scratching my head as to what on earth might have created this. So about 1.5 years ago, I read his book, The Rocks Don't Lie, and in it he has a piece in the chapter about the so-called scablands in eastern Washington, where this lake, about 15,000 years ago, Lake Missoula, burst forth and flooded that part of eastern Washington and created the landscape. And all of a sudden, I realized that what I was seeing was the result of this giant flood. And so all the stuff that I didn't know how to interpret came together in one flash of insight, and I thought that was just absolutely marvelous. So I was delighted with his book, and this was one of the motivations for inviting him here, because it's cross-disciplinary and it's a fascinating topic. So without any further ado, David, welcome to hear you talk about faith in nature.
I'm a geologist by training, as you've just heard, and one of the things that I've been asked about by this book, and you may be wondering, is why would a professional geologist in the 21st century write a book about Noah's flood? I hope that about 40 minutes from now, you'll sort of see the path that I took in sort of coming to write a book about Noah's flood and share the sort of the interest and the excitement and the thinking of the history and development of the science of geology. Something that I wasn't really formally taught in any detail other than what I now know as a cartoon version. But also as I started looking into the history of thought in Christianity, the way theology looked at the idea and thought about the flood, and the way that sort of tension between faith and reason that has been portrayed in a lot of histories was actually a lot more complicated and interactive and cross-pollinating than I ever really knew about. So I invite you to sort of share with me the story of how I sort of went through writing this book, The Rocks Don't Lie, and where it really started was in southeastern Tibet. I had no sort of knowledge that I was going to be sort of researching and looking at the effect of really big floods and the origin of flood stories until I got asked to join a scientific expedition to the southeastern Tibet, to the gorge of the Tsangpo River. I was the token geomorphologist. They needed a river person on this project, and I was the guy that sort of knew some of the people involved. They asked me if I wanted to go on this expedition to Tibet, and I was like, sure, I volunteer, no problem. What do I need to do? What am I studying? And as it so often turns out, the thing that we actually proposed to do in geomorphology was not the thing that I got really excited about after I got there and saw the landscape and started reading pieces of it. Like this piece that you see behind me. This is a topographic terrace. It's a lake terrace in the valley of the Tsangpo River, upstream of the gorge where the river flows down through the Himalaya, carves one of the deepest canyons on Earth, and then flows out to become the Brahmaputra where it gets down into India. This is in the eastern corner of the Himalaya where the Tibetan border hits India and Burma or Myanmar, whatever you want to call it. This valley is a very interesting place. These very prominent features are essentially tell me, as a geologist, that there had been standing water in this lake. For the geologist in the audience, it's a Gilbert-type delta. There's foresets and topset beds. But basically, for the non-geologist, there was a lake that reached at least up to about that level at some point in the geological past. And we found sort of example after example of these terraces going downstream through this valley that I had not really thought were there when we proposed to go study it. And I started realizing that, hey, there was a really big lake that had been in this valley sometime in the geological past. We started collecting samples out of these terraces to try and ascertain their age. And there was one really big problem, though. As we were driving downstream, following the course of this river, mapping terrace after terrace, you could project the water level from these lakes right out through the gorge of the Tsangpo River. In other words, there was nothing to hold the water in. And so we started puzzling over, well, what was the dam? What actually created these lakes in the first place? And when we got down to just near the head of the gorge of the Tsangpo River, we found our candidate, which is essentially these glacial moraines, these piles of earth that were bulldozed by a glacier that came off the high peak of Namche up here as ice at some time in the past, bulldozed these giant moraines up. And you notice it's truncated here. These moraines had extended all the way across the valley. You can find scraps of this glacial debris on the far side of the valley. It dammed the river. What happens when you dam a river? Well, you get a lake behind it. But what happens when you dam a river with a wall of ice? That's not exactly the best thing in the world to make a dam out of, is it? And what happens is essentially, well, you float the dam, you release the lake. It's a recipe for causing a really big flood. And the truncated nature of these moraines sort of augured for the occurrence of these big floods in the past. And I got really excited because this is not what I'd gone to Tibet to try and work on. And you know, in the process of science, when you discover something unexpected, you know, that really is where a lot of the joy of doing science comes into it. And so I got really excited, was really thrilled about this. And I started to then talk to some of the local Tibetan villagers about how thrilled I was to have discovered that their valley had been filled with a lake at some time in the past, and that a really big flood had drained the lake and essentially created the landscape, the topography, the geomorphology that we could see today. And this sort of story was translated from English to Chinese to Tibetan, back to Chinese, back to English, and the reply that I got really kind of shocked me, because it was basically something like, oh yeah, I know about that. There were 3 boats stranded up there on the side of the valley when the lake drained. And I'm sitting there thinking, you know, I just discovered this thing. How could you know about it? Basically, there was an oral tradition of this lake draining, or a lake draining in this valley that I was unaware of at the time, or before this trip. And I was even more surprised when we got our carbon dates back from some of the lake sediments. And they dated out at about the 8th century AD, about 1,200 years ago. I think that's the late Tang Dynasty, if I'm remembering such things correctly. And it turns out that there's this story of this gentleman shown on the screen behind me, Padmasambhava, Guru Rinpoche, the second historical Buddha, the Tantric Buddha, the guy who introduced Buddhism into Tibet through the valley of the Tsangpo River by doing things like, yes, draining the lake by fighting the demon of the lake and essentially draining it to reveal the fertile farmland that the people still farm today. So in other words, had I not done the geological field work ahead of time to put the story of this lake together, and if I had heard that story, I would have considered it a folk tale, a folk story, something that, you know, maybe they saw these kind of features I was seeing and it was made a story to try and explain the topography. But this made me start to wonder whether or not there was a real geological basis to the story of many of the world's flood stories. Because it seemed like there's at least a very plausible case to be made for this one in Tibet, having its roots in an actual event that may have occurred some 1,200 years ago. Well, this got me into thinking about things like, you know, the world's other flood stories, as you might imagine it would. And I started to look at things like the global distribution of flood stories. And you know, many people have done this in the past. But if you kind of look at it and parse the geography and the details in some of those stories, you actually can put together some fairly interesting observations. But you know, their flood stories are from around the Pacific Rim, sort of in this region. They're across North America, from Alaska across the Midwest up into Scandinavia. And of course, there's a few very famous flood stories, or one in particular, out of the Middle East. What about that distribution? Well, I'll turn to that in a minute, but what first about the characteristics of flood stories? A lot has been made about the parallels between flood stories in different parts of the world. And the most common elements among the world's flood stories are really that people survived destruction by water through some type of a boat or ark, and many of the other details actually vary a lot between different regions. But those key elements, essentially that there was some means of escape, that the flood was caused by water, well, that's kind of a no, that's a gimme, right? And that somebody was saved to tell the story. Those are the three elements that you would have to have in terms of any flood story in order for the story to have been recorded, and been essentially transmitted. I got really interested then in the differences between flood stories, not the commonalities. They are distributed around many parts of the world, not everywhere. But the other question you need to wrestle with in terms of thinking about whether or not oral traditions like this actually could relate to real events is how long could you actually expect an oral tradition to survive transmission and still faithfully tell of a story. The best example I can find of one that seems to be pretty clear is the Klamath Indian story recorded in 1865 that reads an awful lot like an eyewitness account of the eruption of Mount Mazama, the one that formed Crater Lake about 7,700 years ago. If you read that and sort of filter it through the differences in culture and state of scientific knowledge between the Native American community in the Klamath region some 8,000-ish years ago and today, you can basically read it as almost an eyewitness description of the eruption. And if that's right, it suggests that oral traditions could at least have been transmitted down through on the order of 7,000 to 8,000 years. That number will come back a little later in the talk. But it basically suggests that there may be something to the idea that stories of real geological events could survive transmission to become some of the world's oldest stories. Now, if you look at some of those details of different flood stories around the world and parse them a little bit, there's sort of two areas that I'll go into. The first is tsunami stories. There's an awful lot of the world's flood stories that do not involve rainfall. And this greatly mystified Christian missionaries to the South Pacific when they ran into stories in Tahiti and Fiji where the natives knew all about the flood, but it didn't come from the sky, it came from the sea, and it came unexpectedly. And they kept canoes at the ready in case it would come back again someday. Stories that read a lot like tsunamis have been recorded in Alaska, South America, the Pacific Northwest, the Pacific Islands, as I mentioned, Southeast Asia. And one in particular that I'm fond of is the native story from the coast of Chile that tells how two great serpents vied to see who could make the sea rise more, causing an earthquake and sending a great wave onto the shore. And there's parts of the world where you have what are known to geologists as subduction zones, where you have one tectonic plate being shoved underneath the other, where you get great earthquakes, like I hope doesn't happen in Seattle anytime soon. Basically can generate fairly large tsunamis that if you read a lot of these native stories in these areas, they sound an awful lot like eyewitness descriptions of tsunamis. Similarly, if you look towards the northern margins of the Great Pleistocene ice sheets, the sheets of ice that occupied the poles during the last major glacial periods, there's stories in Scandinavia, the one I told you about in Tibet, some in Alaska, some from Oregon and Washington, the Great Lakes region, the Mississippi Valley, that read like essentially dam break floods, and they're probably related to events in those areas. The one I'm particularly fond of is the one captured in that cartoon cover there that shows how Odin and his brothers killed Ymir the ice giant, causing his blood, which of course would be water from an ice giant, to gush forth in a great flood, which drowned a whole lot of animals and is sort of central to Nordic mythology. There's similar kinds of stories from Native American communities, but the geography is essentially circumpolar in the northern hemisphere for the ones that involve ice. Now, I'm not the first person by any stretch of the imagination to wrestle with the geography of flood stories worldwide. A lot of people have done so. And about a century ago, a guy named James Fraser wrote a book called Folklore in the Old Testament, where he actually compiled a list of many of the world's flood stories and then went through them and sort of thought about what they might represent and tried to parse them into which ones were myths, which ones were legends. And his conclusion is worth reading, I think, in full because it's 100 years old and it's very good. And he actually came to a very similar conclusion to what I came to based on, frankly, less work. He wrote that there seems to be a good reason for thinking that some, and probably many diluvial traditions, are merely exaggerated reports of floods which actually occurred, whether as the result of heavy rain, earthquake waves, or other causes. All such traditions, therefore, are partly legendary and partly mythical. So far as they preserve reminiscences of floods which really happened, they are legendary. And so far as they describe universal deluges which never happened, they are mythical. He was essentially arguing, along the lines that I was a moment ago, that you could sort of look back at real events underpinning some of these, and that some of the stories may be somewhat elaborated. And to be fair, there are some of the world's flood stories that I can't make any sense out of at all. But I won't be talking much about them today. So what about the historical basis for the biblical flood story? I mean, if you're going to deal with the world's flood stories, you can't really ignore that one, can you? And I'm certainly, again, not the first person to wrestle with this, and I'm not going to be the last. But I do think that there's some ideas that really don't hold up to scrutiny at all. Notice the source, the prestigious journal that the article is taken out of. A decade ago, the claim was made that Noah's Ark had been found on Mars in the World Weekly News. And I want to walk you through this example for the simple reason that sometimes, even if you take somebody's argument at face value, you can use their own logic to destroy their argument. And this happens to be one of those examples. So how is that? Well, okay, you notice the picture of the Ark here. That's not actually the picture that they claimed came from Mars. That's an artist's rendition, obviously. This, though, look, actual photo of Martian mountain peak. Okay, so this is the photo of the outcrop right here that is said to look like this Ark. Now, how did they actually get this amazing photograph of Noah's Ark on Mars? Well, they got it with a satellite that was basically shown over here. Now, you get where I'm going with this? What's the problem here? You've got a satellite image. What do satellites do? They look down, right? Okay, notice the perspective on their actual photo of the Martian peak. It's looking up. So if this is an actual photo, it was taken the moment before that satellite crashed. And I'm not aware of NASA having that kind of an accident with a satellite that was looking for Noah's Ark. But in any case, this is sort of a nice example of how you can take essentially an argument that someone would make and follow it through to its logical conclusion, and it just, pardon the pun, doesn't hold water. Well, so what about other ideas about the possible origin of the story of Noah's flood? I actually think that there's two possible sets of events that may be recorded in the biblical flood story. The first was really proposed by a guy named George Smith, who in 1872 translated an Assyrian flood story that bore a striking resemblance to the biblical flood story. Smith's story, his backstory, is that he grew up in the early 19th century in England and was fascinated by discoveries in the Middle East of cuneiform writing. And he actually taught himself how to read cuneiform writing, the sort of the indentations that were made with a stylus onto wet clay and then baked into what became these tablets that recorded a lot of economic data, as it turned out, and then also great stories from the region. And Smith got hired by the British Museum after a calamity happened where archaeologists had been excavating at, I have to go back and read my own book, I forget where they were at, Nineveh, I believe it was. And they had essentially packed a whole bunch of these clay tablets that they had found and put them into crates, shipped them back to the British Museum, but they didn't pack them very well. And so when they got back to the British Museum, what they had thought were all these sort of clay tablets, this sort of like odd pottery that they had discovered, turned out to have been fragmented into tiny bits, and then they realized that all the indentations on it was actually writing, and what they had basically done is shipped a whole library home to England and destroyed it in progress, in transit. So they essentially ended up with the world's greatest jigsaw puzzle with the world's oldest books. Smith basically got hired to comb through these little pieces and try and put these books back together to try and figure out what they said. And he spent a decade toiling in the basement of the British Museum trying to figure these things out, and then he finds this piece here, which basically tells the story, when he translated it, of a righteous man who was warned by a god of an impending flood and told to take his livestock and his family, put them on a boat. They did so. They rode out through 7 days and nights of rainfall, crashed onto a mountain peak after releasing 3 birds that went out to go look for dry land, and then there was a rainbow, and they built a fire and made an offering. That's the story of Noah's flood. It's the biblical flood story. But it predates the Bible substantially. And this made big headlines in England back in the 1870s when it was discovered. The Prime Minister of England shared the stage with Smith when he essentially announced his discovery of essentially an idea of the story of Noah's flood. And so what is it about this area, this region, that may lend itself to a geological basis for the story of Noah's flood? Well, has anyone been to New Orleans before Hurricane Katrina and sort of gone to the convention center and looked at the sign that's about 4 or 5 feet over your head that says sea level? This is a fairly disturbing thing for a geologist to see and stand below. And it turns out that in big river deltas, you'll often find that the high ground is right along the river and the levees of the river, and land slopes off to the sides. Why? Well, when it floods, the coarse sand settles out right by the river and it builds the high ground like the French Quarter is on. The far areas, though, when the river overtops its banks, as big rivers eventually do in a big enough rain somewhere upstream, basically the surrounding terrain fills like a bathtub. Well, the delta of the Tigris and Euphrates rivers was very similar. And there were very large prehistoric floods in the region. It's possible that one of those actually flooding the valley wall to the wall at a depth that you couldn't sort of stand in and survive would have been the origin of the story of Noah's flood. I mean, I can't tell you that it's not. I can't, on the other hand, tell you that it was. But I think it's a potential candidate. It's a geologically plausible argument for what could cause a big flood in the region where the story can actually be traced back to its ancient Sumerian roots. Well, the other possible, I think, geological explanation for the story of Noah's flood is a proposal that was put forward by a pair of oceanographers, Ryan and Pittman, their Black Sea hypothesis. And it's basically rooted in the idea that as at the end of the last glacial period, as ice melted off the poles and sea level rose, there was a last gasp of meltwater coming off of North America that raised sea level just enough to decant the Mediterranean into the Black Sea. Almost 8,000 years ago. And what happens when you basically connect a large body of water at a higher elevation to a smaller body of water at a lower elevation where, well, the lower one fills up to the level of the higher one. And you'll notice in the bathymetry of the Black Sea here, here's the Bosporus where the Mediterranean is thought to have spilled into the Black Sea. Notice all this sort of flat land essentially on the margins. Ryan and Pittman basically suggested in a book, I think, called The Noah's Flood, a decade or two ago, they argued that this event, filling up the valley of the Black Sea very rapidly, probably drowned some of the world's earliest farming communities, and that the story of that traumatic event may have been preserved in the story, in stories of great floods for peoples that sort of fled in different directions, including the ancestors of the ancient Sumerians who brought the story of the Great Flood to ancient Sumeria, where it then became the story that Smith then discovered later. And I'm not going to argue to you which of these two events is more likely to be the origin of the story of Noah's flood. Frankly, I think you can make a good case either way. But what I was really intrigued by when I was doing the research for this book was not so much those ideas, because I was vaguely familiar with both of them. But what I was really intrigued with was how, well, scientists immediately started arguing about, well, did the Black Sea flood happen? When did it happen? How many times did it happen? How much did it fill up when? And we're still arguing about elements of that, I believe. Creationists were really starting to argue about, were immediately outraged that here were some scientists claiming to have found geological evidence that might be interpreted as supporting a biblical story. And they're actually outraged, and that intrigued me because I didn't really understand why that would be. I thought they might be really happy with this. And it turns out that the more I started getting into it, the more I sort of realized that, well, Ryan and Pittman had discovered the wrong flood. They had discovered a flood that only involved a small area, not covering the whole world, and that there's a subset of Christianity that believes that Noah's flood, that still believes that Noah's flood actually covered the entire world. And so these guys had discovered evidence for the wrong flood, so they must be wrong, and therefore they should be outraged. This set me off on a path of trying to actually try and understand the history of thinking about what you might call natural philosophy or natural theology in Christianity, to try and understand, well, where did this sort of level of outrage, that this blowback that Ryan and Pittman received, where did it actually come from? What were the roots of it? And so I started looking into early Christian natural theology and ran across works like those by Origen, who in the 2nd century AD, in writing about the first chapter of Genesis, wrote that, now what man of intelligence will believe that the first and the second and third day, and the evening and the morning, existed without sun and moon and stars? I do not think anyone will doubt that these are figurative expressions which indicated certain mysteries through a semblance of history and not through actual events. In other words, there's been a long-running conversation and argument within Christianity, dating back to the very earliest days of Christianity, about how to interpret the stories that are in the Bible that relate to things that geologists now study, like the origin and age of the world and things like really big floods and the shaping of topography. And with my background, I was not fully versed in that, not aware of it, and I was very intrigued by this long-running sort of argument and between the engagement and relationship between faith and reason. St. Augustine in the 4th century AD also weighed in on things like this, and when he wrote that, "Let no one think that because the psalmist says he established the earth above the water, we must use this testimony of Holy Scripture against these people who engage in learned discussions. Ignorant of the sense of these words, they will more readily scorn our sacred books than disavow the knowledge they have acquired by unassailable arguments or proved by the evidence of experience." Augustine was arguing quite explicitly against Christians adopting views of the natural world that could be contradicted by direct observations of the natural world, because he then believed that would make it very difficult to sell other people on the religion itself. And he also, though, believed that Noah's flood was a global flood. But he believed this based on the application of reason through what he saw in the rocks. Why? Well, what he basically saw were seashells in rocks on mountaintops. And if you have marine organisms embedded in the very structure of the world at the highest elevations in your landscape, and he was in northern Africa, where this is essentially the case, you can interpret that in one of two ways. Either the sea used to cover the peaks, and then there was water up above there, and that's how the marine organisms got there, or the mountains rose from beneath the sea to where they are today. And in his day, the latter was the more outrageous thing to assume. St. Thomas Aquinas, in the 13th century, also accepted the reality of a global flood, pretty much for the same reasons. You could see fossil marine organisms in the rocks on mountaintops. But he explicitly argued for understanding nature, what he called God's other book, in seeking to understand both Scripture and the world around us. His basic argument was that since, in his view, God wrote the Bible and created nature, those two areas in which you could investigate and think about the nature of truth had to tell the same story because they shared the same author. And in other words, if you learned something about the nature of the world, you should have enough faith in nature and in God's creation of nature to essentially think about reinterpreting any elements of the Bible that were in conflict with that, because in the end, the two could not be in conflict. We all sort of know the story of how Galileo was subject to house arrest for doing, outrageously naughty things like training a telescope at the heavens. But I got very interested in sort of how his motivations, and he was not really trying to attack the Catholic Church with his investigations, obviously. And one of my favorite quotes from him about this time was, "I do not feel obliged to believe that the same God, who has endowed us with senses, reason, and intellect, has intended us to forego their use." This is a quote that I think is as pertinent in modern politics as it is in Galileo's day. But in terms of Galileo's direct connection to the Catholic Church, he wrote in a letter to the Grand Duchess Christina in trying to explain his views and why he was not really trying to set up his ideas in conflict to the Church. He wrote that if anyone shall set the authority of Holy Writ against clear and manifest reason, he who does this knows not what he has undertaken. For he opposes to the truth not the meaning of the Bible, which is beyond his comprehension, but rather his own interpretation, not what is in the Bible, but what he has found in himself and imagines to be there. In other words, he was basically arguing that if we discover things as rational beings about the nature of this world, the process that we now know as science, if that stands in conflict with what one interprets in a book like the Bible, then maybe it's the interpretation that ought to be closely re-examined as the first step. Well, let me return back to geomorphology, because the digression there through a micro history of theology was one I really had to go through myself in terms of trying to understand the nature of how people have looked at flood stories through time. And it was fascinating, but it took me more time than I thought it would to write this book, because the story was a lot more interesting in terms of the cross-pollination between science and religion. But so back in the 17th century, the theories for topography were essentially the three that are shown up there on the board, thinking about how landscapes were shaped. Landscapes were shaped either on the third day of creation. They were made the way that we see them today back when they were made. In other words, they haven't changed much, which means the job for geomorphologists would be really easy. We just do a one-off, that's the way it was, we're done, right? Secondly, that topography was carved by Noah's flood, essentially that the world's topography was a direct consequence of human misbehavior and sin, and that topography, was the world we know today and walk around on, is the chaotic aftermath of the flood. The idea that all the world's sedimentary rocks and the fossils that are contained within them were laid down by the flood was a very central argument in the 17th century. And finally, there had been enough earthquakes in those days to essentially acknowledge that they played a minor role in shaping the land surface. But those first two were really the theoretical framing devices, the theories, if you will, which 19th century 17th century, excuse me, natural philosophers essentially framed their view of geology. And it turns out that the first person who really put together a very comprehensive sort of theory of the world, called it the sacred theory of the earth, was not a natural philosopher at all. He was a theologian. He was a Cambridge theologian, Thomas Burnet, who wrestled with the problem that was seen very much as a current one in those days, that there wasn't enough water on earth to explain Noah's flood. People they had sort of added up how much water was in the clouds, how much water was sort of circulating in on the surface of the earth. And it was you couldn't essentially cover the world's highest peaks with the water that was there. And so Burnet came up with what was actually a very clever solution to the problem. He basically argued that the world, when it was created, was essentially an oblate spheroid, an egg-like thing, we'll just call it a sphere, that was basically had 3 different layers in it. And that the outer layer was a layer of rocks and stones that form the surface that we walk around on. There was an inner layer that was an interior ocean, and there was a very metal-rich, dense core. And this 3-layer configuration allowed him to propose a very clever idea for how Noah's flood could have occurred when you couldn't find enough water on the surface of the earth today to explain it. And what he basically said is that when God created the world, the sun started to then heat up the outer crust of the world, which started to fracture and crack, and right at the peak of human wickedness, the shell of the earth collapsed into that interior ocean, generating Noah's flood, and then the waters all drained back down into the rocky rubble of the mess. So the water was hiding somewhere within the earth. And this was actually a very clever idea, but he ran into a lot of flack immediately. The first, as you might imagine, if you've ever tried to float a gravel on a glass of water, it doesn't work very well. It would be very difficult for his exterior shell to float on top of an interior sea. From this, and you can run the experiment yourself with a glass of water. So he originally caught flack from natural philosophers, but he also caught a lot of flack from theologians. Why? Well, imagine the theological problems if, with the setup for the biblical story of Noah's flood, if God created the world pre-programmed for destruction, then God knew we were going to fail the test of being good or wicked, and so why put us through it all in the first place? There's certain theological problems that come, and so he got attacked by both theologians and natural philosophers. And this is not one of those cases where if you make everybody mad, you're doing the right thing. Sometimes it means you're actually just wrong. And even the founding father of geology, the person that I learned about in my history, what limited history of science I was exposed to as an undergrad or grad student, he's the person that we look to as sort of as the founding philosopher, if you will, of geology, because he proposed founding principles that are still used today to interpret the rock record. And he did this essentially because he was working for the Grand Duke of Tuscany, Ferdinand II, I believe it was. And he was trained as a medical doctor, and he's a master dissectionist. So when some fishermen, pulled up a great white shark and cut off its head and sent it up to the Grand Palace, Steno was the guy who got the job of dissecting it. And in the 17th century, a public lecture like this would be, I'd be cutting something up here, and we'd all be sort of fascinated by the grossness of it all. But this was essentially. So public lectures in those days, he got the job of dissecting this great shark. And what he noticed when he did that was that the teeth of these sharks were identical to things known as tongue stones. They were like dead ringers, as close as 2 eggs to one another was his quote. And when he realized, and what tongue stones were things that people found weathering out of rocks. They didn't know whether they were petrified lightning strikes or what they were. Steno said, no, these are shark's teeth. And he nailed it. He basically convinced people of that with the treatise that he wrote on it. But it brought up this problem of, well, if sharks' teeth are eroding out of rocks that are in mountains, how did the teeth get in the rocks in the first place? And that's what started Steno off in thinking about his principles of geology. And the ones that he came up with were actually fairly simple, and we still use them today. If you have a pile of sedimentary rocks that have been deposited by stuff settling through water, well, the oldest stuff is on the bottom. The youngest stuff is on the top. No one's going to argue that. And Steno basically tried to express his principles in his words as to be so clear that nobody could really object to them. In other words, if you apply them, the inferences you draw from them are correct. And he also, his second principle was that the stuff was laid down horizontally. So if you found rocks that are tipped up on their side, they've been tipped since they were deposited. Very clear, very simple, still taught in introductory geology ideas. Notice that with his garb here, at the end of his life, he was a Catholic bishop. That point will come back. What did Steno then actually sort of do? He applied his principles to interpreting the topography of the area around of Tuscany, and he came up with a 6-stage model for the history of the world, the 3rd stage of which was, you guessed it, Noah's flood. So the grandfather of geology, the person who basically laid down the founding principles, was interpreting the evidence that he saw through applying those principles through the theory of Noah's flood, a theory with quotes, right? But the idea that he was filtering his interpretation through that as his view of it. Now, after Steno basically demonstrated that fossils were actually real objects, they weren't just things that happened to be petrified within the world, they were the remains of real organisms that died in real events and got buried in real rocks. The recognition that fossils were real things was seen by many as compelling evidence of Noah's flood. As you have a lot of bones in the rocks, a lot of fossils, those may be things that were essentially drowned. And this fossil over here, Homo diluvi testes, that was popularized by Jakob Scheucher, a Swiss naturalist in the early 18th century, was held for as a solid evidence of Noah's flood in terms of being a drowned sinner. They thought it was a human fossil. It turns out it's actually a giant salamander, but this wasn't actually figured out for another 50 or 100 years, depending on which source you want to cite. But the point is that people started looking at and thinking about bones they found in rocks and thinking about tying them back to organisms, and early on they were seen as compelling proof of Noah's flood. There were bones of mammoths that were unearthed in upstate New York that were interpreted to show that Adam was well over 100 feet tall, based on the verse in the Bible that talks about there being giants in those days, and the idea that if you look at the femur of a mammoth, other than its great size, it kind of looks like a human femur, kind of the way a giant salamander that's been squished and buried in rock looks like a person that's been squished and buried in rock. But if you interpret that giant leg bone as from a human being and you back out the scale of them, they were gigantic. This all really started to change, I think, when a Scottish farmer discovered evidence for what we now call geologic time off the coast of Scotland. This is James Hutton. He was a Scottish farmer who was very interested in thinking about the way that the surface of the world worked. He was motivated in part by watching sand erode off of his fields and noticing that what was leaving his fields was very similar to the sand that was actually in the rocks that he used to build the walls around his fields. And he started puzzling about sort of long periods of time and how those kind of things could work. He basically found evidence at this outcrop called Sicker Point, just east of Edinburgh, for Earth history being much longer and involving much deeper time, although he didn't use that phrase, than people had thought at that time, when the general thinking was that the world is a few thousand years old, based on Bishop Ussher's famous accounting of time from the Bible. What is it about this outcrop that did that? Well, notice there's these vertical rocks, these gray rocks in through here. These are actually gray. They're stained red from these upper ones, but they're gray. They're poking through back there. But there's like sandstone that's standing vertical, and then another packet of sandstone that's on its side tilted, and there's what's known as an unconformity running through here, a boundary between these two packets of rocks. Now, if you take Steno's principles that we just went over a few minutes ago, that sedimentary rocks that are laid down, the oldest ones are at the bottom, and they're laid down flat, you can basically unpack, if you will, this outcrop to realize that this is the oldest stuff down here. Why? Well, it's on the bottom, and it's standing vertical. It wasn't formed that way. So you can basically read the story and they're made out of sand. If you got up there and broke a piece off, you'd see they're sandstone. They're basically made out of sand that's been lithified or turned into rock. So you can basically know that this material got laid down flat at the bottom of an ancient sea as sand. It had to have eroded off of some mountains or upland somewhere to actually get there. It was deposited. There was a stack of it deposited. It got buried deep enough to be compressed into hard rock because this unconformity cuts in. Well, then it got tipped up. So it's buried, tipped up, eroded off, then more sand is deposited, and again, it was flat. Then it gets buried deep enough to be turned into rock. Then it gets tipped up and then uplifted enough to be exposed on the coast today. What Hutton realized this meant is that the story told by this one simple outcrop was far more complex than could be fit into the biblical story of an initial creation followed by a single flood as explaining all the world's topography and geology. Why? Well, there's two generations, two periods of deformation. This outcrop tells the story of the life and death of two mountain ranges. And that's one catastrophe too many to fit into the biblical narrative. Hutton basically argued this indicated that geological time was essentially vast and almost unknowable in its scope. And again, that is one of the hardest things for novice geologists to wrap their mind around, is the great depth of geologic time still. So by the 18th century, in the 18th century, as scientists started to apply Steno's principles to the geology of Europe, they started to realize that there was actually multiple periods of geologic time. They were starting to discover that there were more periods of geologic time than you could fit into the biblical narrative. And if you just took all the little layers that you could trace across great areas in Europe, thought about the time it would take for that material to settle out, and then integrate it up, you're starting to get well over the single year that's allowed in the biblical flood narrative. So the next piece of the puzzle that I wanted to add was essentially involves fossils. And that's the story of Georges Cuvier, a French scientist who was a vertebrate anatomist. And he was the type of scientist who does not do field work. People sent him bones. He was the bone guy. You found a bone somewhere in the world, you sent it to Cuvier, and he would interpret it for you. And he was, by all accounts, brilliant at that. And when Napoleon's army sent back samples of elephants and elephant heads and tusks and their molars, he basically compared the morphology of African elephants, Indian elephants, and mammoths, and realized that the skulls that we know now as mammoths that were dug out of rocks, fossil skulls, bore no resemblance to any living elephants. What Cuvier discovered, in other words, is he discovered extinctions. And extinctions caused major theological problems, because what was the story of Noah's flood supposed to do? Well, Noah was supposed to save 2 of everything. And apparently he didn't save the mammoths. No one had ever seen a living mammoth, and everyone had always assumed that mammoth skulls that were being unearthed were basically elephants that of one stripe or another that had died in the flood. And Cuvier went on to actually study the organisms, the plants and animals in different layers of the rock record, and managed to document that at each of these different periods and eras of geological time, there was a different flora and fauna. And what he basically inferred from that was that the life on Earth had been created not once but many times and destroyed many times. In other words, there was a whole series of great catastrophes, far too many catastrophes than could be accounted for in the biblical narrative. And finally, and as this sort of geological discoveries were going on, the idea of which of these great catastrophes was actually Noah's flood was an area of active debate and argument in early 19th century geology. And the Reverend William Buckland, who was the first professor of geology at Oxford, originally came to fame by claiming to have discovered solid geological evidence for Noah's flood as the most recent of Cuvier's grand catastrophes, in the sort of the layer of gravel and cave-filling sediments that blanketed northern Europe. But eventually, when Louis Agassiz, the guy who the hall next door is named after, demonstrated that the ice ages actually were responsible for laying down that blanket of gravel and those odd stray boulders that they're all over the place in Europe. It basically eliminated the last traces of geological evidence for a global flood. So we can recap that the geological hunt for Noah's flood started in the 17th and 18th centuries, and as people started to apply Steno's principles to studying nature, to studying Earth's autobiography, they realized that the rock record involved more events than simply the creation and the flood. There was more to the natural narrative than actually got folded into the biblical one. And in the late 18th and early 19th centuries, the flood was thought to be recorded in the superficial deposits that recommended just the most recent of those catastrophes. But by the 1830s or 1840 at the latest, it was pretty widely acknowledged within the geological sciences, at least, that there was no physical evidence of a global flood. By the mid-19th century, it was very well established that geological discoveries had essentially refuted the idea of a global flood. A book, The Religion of Geology by Edward Hitchcock, the president of Amherst College, who's both a natural theologian and a geologist, and that's to prompt me to remind you that most of the people we've been talking about so far, not all of them, but most of them that were involved in the early study of geology were clergy. Those are the people who had the time and the expertise and the energy and the interest to actually go out and study how the world was put together and to try and understand the processes that had been used to shape and form it. Hitchcock's summary here, I think, is well worth sharing for 2 reasons. One, it's interesting, and I like 19th century writing, yes, I will admit it. But also, note the date. It's from 1854. This is from before Darwin's famous book. Hitchcock wrote that the history of opinions respecting the deluge of Noah is one of the most curious and instructive in the annals of man. Almost every geological change which the earth has undergone, from its center to its circumference, has at one time or another been ascribed to this deluge. And so plain has this seemed to those who had only a partial view of the facts, that those who doubted it were often denounced as enemies of revelation. But most of these opinions in this dogmatism are now abandoned, because both nature and scripture are better understood. From what I can triangulate, by about the mid to late 19th century, the idea of a very young Earth shaped by Noah's flood had been completely abandoned by geologists and had been pretty much abandoned by mainstream Christian theologians, who had basically bought into the arguments that, Augustine and Aquinas' arguments about God's two books being in agreement with one another. And by the end of the 19th century, geologists, well, by the mid to late 19th century, geologists had really moved on from the idea of studying Noah's flood. There were arguments about, was it a regional flood in that Caspian Sea. Charles Lyell, a guy who wrote a very famous book that sort of kicked off modern geology, wrote about Noah's flood being from the flooding of the Caspian Sea. It's kind of Ryan and Pittman's hypothesis, one big sea over. And there were lots of arguments about sort of what may have been the other thing, but the idea of a global flood was pretty much put to bed. And geologists really started to essentially not look at evidence for really big floods. They weren't looking for them. The idea of grand catastrophes as things that could shape the surface of the earth fell wildly out of favor. And a guy named J. Harlan Bretz in the 1920s, in his youth, actually had the audacity to discover evidence for those big Missoula floods that you were talking about a little earlier, when a glacial ice dam blocked the South Fork of the Clark River, created Glacial Lake Missoula, and notice this is Seattle over here under a lot of ice in the Pleistocene. But when this ice dam failed, this lake drained out and carved the channeled scablands of eastern Washington. Landforms that really, if you aren't thinking in terms of a really big flood, are really cryptic and hard to understand and at a scale that's really hard to see. Well, Bretz figured this out on horseback and in a car in the days before you could actually get up in airplanes to figure it out. You can look at NASA satellite imagery today and it'd be a lot easier to put the story together. Bretz did an incredible job of doing the field work the old school way. Why? Well, he was old school. He was working in the 1920s and 1930s, and most of his geological colleagues didn't believe him for most of his career. Why? Well, because we'd already put to bed the idea of really big floods shaping topography. You know, the war over Noah's flood had been solved in the 19th century. He couldn't possibly be discovering this kind of stuff. It took most of his career and most of the 20th century for geologists to actually come around and for his views to be vindicated in terms of looking at what shaped the topography of eastern Washington. And the happy resolution of this story is that he was essentially recognized by the Geological Society of America before he died. The downside is that it wasn't until he was in his 90s, and so he didn't, I think most of the people he had fought with most of his career had already died. Geologists really, over the course of the 20th century, came back to sort of thinking about the tension between the slow and steady processes that shape the surface of the earth every day and these kind of grand catastrophes that Cuvier and Bretz were talking about. And so today now, any sort of student coming out of an undergrad or graduate program in geology is going to have the tools to both look for evidence for big catastrophes and to integrate up the day-to-day processes that, say, Hutton was thinking about in terms of his deep time. We sort of look at things through both lenses. Well, if we look at the state of sort of public awareness of geology today, and we look at Gallup polls over the last 30 years or so, from 1982 up to 2012, and we look at the proportion of the American public who essentially buy into the arguments of young Earth creationism. The world is actually fairly young. It was created in the shape that we know it today, and presumably that Noah's flood played a big hand in shaping that. It's something on the order of 40 to 45% of the American public, scarily close to about half of the American public. And you'll notice that I haven't talked about evolution at all yet. And I'm not going to. Why? Well, I'm a geologist that studies things other than paleontology, although I will show one slide in a minute that we'll get back to that a little bit. But I was very intrigued by how so much of the American public could still believe things that the geological foundation for had been utterly disproved before Darwin ever got on board the Beagle. And so I went and visited the Creation Museum in Petersburg, Kentucky. Now, I did this with a colleague, and it was very interesting. It's an incredibly well done museum. What you first see when you come in is you essentially see Eve sitting here feeding a squirrel a carrot, and there's this Jurassic Park velociraptor hanging out next to her very comfortably and not going for her or the squirrel. I think he's going after vegetation, because as exhibits later there, and this thing would tell us that carnivores were actually vegetarians in the Garden of Eden. You also find, though, things like a triceratops with a saddle on it. Why? Well, if, as this museum argues, that the whole history of the geological history of the world involves the original creation and then Noah's flood, which deposited all the sedimentary rocks that have all the world's fossils in them, then all those dinosaur bones that we find had to have been of creatures that were living right before the flood. And therefore, since there were people before the flood, the dinosaurs and people had to live together, and presumably not unlike in the famous town of Bedrock, where everybody was happy and got along. The things that really surprised me much more, though, were the nature of some of the exhibits actually within it. When you go into one of the first exhibits, you see reason explicitly defined as the enemy of faith. And having been brought up in a Presbyterian household that was taught fairly different things, I was quite surprised by this. The displays essentially dismiss reason as the enemy of faith and specifically accuse scientists of a centuries-long conspiracy to question, destroy, discredit, criticize, poison, and replace God's word. And each one of those italicized words gets a whole panel where it then goes into discussing the argument. What I couldn't get past, though, is how anyone who's ever been to sort of a scientific meeting and sort of noticed how viciously we attack each other's ideas, how mercilessly we rip each other's ideas apart. I mean, that is what we do as a profession. The idea that we could actually pull off a transgenerational conspiracy to mislead the world about the very nature of science, it's just beyond imaginable. And yet there it is. It's laid out quite clearly. I just don't understand the mechanics of how that could work, although maybe apparently I haven't been inducted into whatever the secret society is that is pulling this off yet. You also find exhibits on how Noah's flood deposited all the world's sedimentary rocks and fossils. No real surprise there at this museum. But the thing that is surprising are there's things like dinosaur footprints in sedimentary rocks, fossilized footprints, sort of what we call trace fossils. And if you think about sort of how the mechanics of that would work, how do you actually form a footprint in a layer of sediment that's being deposited beneath or by a chaotic globe-destroying flood that literally ripped up the surface of the earth, reshaped and redeposited everything everywhere else? You really had dinosaurs walking around on the bottom of the sea during that? Air-breathing dinosaurs? That's what would be required to explain those rocks in those kind of exhibits. And never mind what it would take to explain how you would preserve a pair of mating turtles. So this brought me, I had listed some 100, 150 pages worth of, in the book, The Rocks Don't Lie, of detailed refutations of specific geological arguments that young Earth creationists have made. And those got taken out in the interest of readability, which anyone who reads it should thank me for. But that I was encouraged to think about sort of what are the sort of top 3 reasons for why the sort of the fatal flaws of flood geology, or the idea that Noah's flood really is responsible for the geological record that we have of life on Earth. And the first fatal flaw is the one that Thomas Burnet was wrestling with. There's not enough water on Earth to actually cover the Himalaya. The best graphics of it, though, were in the movie 2012. That was not really the best disaster movie ever, as it says. But there really is a fundamental problem in terms of where all that water came from or went. The other very fundamental problem that I don't have listed up here, but it's one of my favorites, is Leonardo da Vinci's argument about why Noah's flood did not shape the world's geology and lay down fossils. And he had the very simple argument that, well, if there was a global flood and it covered the world, you would have had a spheroidal-ish planet surrounded by a sphere of water. And what would happen? There'd be no effective slope to that water. There'd be nothing to drive the flow. It would be still water. That wouldn't actually rip up anything, wouldn't redeposit anything. It wouldn't do any actual work if you had a global covering flood that actually covered the highest peaks. The second Fatal flaw of flood geology is the problem that was wrestled with and recognized in the 18th century. And that's that the geological record involves a lot more than a single chaotic globe-wrecking flood. And if you just look at the color coding there on the geology of the Grand Canyon, the fact that there's 3 different colors, there's 2 unconformities. You have the basement rocks down here, which a creationist would argue might date from the original creation. Then you have a layer of sedimentary rocks, an unconformity up here, and then more layered sedimentary rocks. Even in their worldview, you'd have to have 2 floods, not 1, to explain this stack of rocks. And we won't even argue about radiometric dating and all the other reasons why you can basically dismiss their argument here, but their own logic does it for us. And finally, what I think is perhaps the most troubling problem with the young Earth creationist view of Noah's flood are that 99% of all fossils are from extinct species. And I have yet to hear a fairly coherent response to this problem from those who claim that all the world's fossils are a result of Noah's flood. Because what this means, of course, is that either Noah did an absolutely terrible job at trying to get 2 of everything onto the ark, and he got like he got the 1%ers, and that's it. Maybe there was a subscription or something. I don't know how that worked. But either he did a poor job of trying to actually fulfill his primary duty, or there's something fishy with the story. That's your choice. So what is it that actually led to the modern revival of young Earth creations? And I mentioned a little earlier that as far as I can tell, the idea of a young Earth shaped by a global flood was pretty much out of mainstream Christianity at the end of the 19th century. And if you go back and read some of the other works by some of the people who signed the fundamentals that started off fundamentalism, they were old Earth creationists. They were not people who believed in a young Earth and Noah's flood shaping the landscape. These views really got revived in great part due to this book, The Genesis Flood, that was published in 1961. It really launched, I think, the young Earth creationist revival, and was by an Old Testament scholar, John Whitcomb, and a hydraulic engineer, Henry Morris, who collaborated on this book. And they were very clear that what they did is they basically took the biblical story as truth and then went to look for evidence to support their interpretation of that story. And they advocated letting the Bible speak for itself and then trying to understand the geological data in light of its teachings. In other words, in sort of scientific parlance, that's sort of known as assuming the conclusion. But they actually, I actually put off reading their book till fairly late in the research process for this, and that was a mistake. I had thought that they basically would be far less rational than they turned out to be. These guys actually laid out a really good and devastating critique of geology of the 1950s. These guys knew what they were talking about in terms of critiquing the way geologists were not able to explain many of the things, the basic features of the surface of the Earth. What, they asked, killed off the dinosaurs? How did great stacks of sedimentary rock end up stranded high on continents above sea level? How could mountains rise? This is back to the question that Augustine is grappling with and why he thought Noah's flood was a global flood. He didn't have a good model for how mountains could rise. How did fossils of tropical flora end up in rocks at the poles? These are all questions that geologists, in the theories that had been offered up to that point had essentially collapsed, and there were no really good answers for them. And these guys were clever enough to figure that out, point it out, frame their book, and then say, we know the answer. There was a global flood that resurfaced the world and deposited all the sedimentary rocks and fossils. In other words, they dusted off Thomas Burnett's long discredited 17th century model. What did they miss? Well, note the date on their book, 1961. Whitcomb and Morris pretty much missed out on plate tectonics. Why? Well, plate tectonics wasn't really accepted at the time. It was barely even proposed. Pieces of it were starting to fall into place in their day. And plate tectonics is a good example of one of those ideas that comes together from different observations that then get put together to make a theory that actually answers questions that the developers of the theory never thought to pose. And in my view, that's actually a characteristic of a really good theory. If you put something together based on evidence, you make a prediction, and then someone else says, hey, that also explains this, that, and the other thing, and pieces start falling into place, that's the hallmark of a good theory. The hallmark of a bad theory is essentially if you have to keep invoking miracles to explain away the observations that don't coincide with your theory. And this is the problem that Whitcomb and Morris ran into. So they basically missed out on the plate tectonics revolution and haven't really looked back terribly since then, and young Earth creationists have been engaged in sort of selectively using and interpreting geological data ever since. But one of the more constructive things that I learned in doing the research for this book, and sticking sort of a couple toes in the water of theology, was that the history of the philosophy and engagement between science and religion is far richer and more nuanced than we sort of tend to see today in the modern media of sort of pitting Bill Nye versus Ken Ham and those kinds of pseudo debates. There's an awful lot of thinking in history and people who've wrestled with the real questions about, well, how do you think about how to read stories in the Bible when confronted with this changing nature of geological science that keeps discovering things about the world? And it's a much richer and more engaging story than I think we tend to think about. And frankly, I think that there'd be a lot more constructive for more people to engage on the real arguments that could be had, rather than the ones that were sort of thrashed out 200 years ago and settled to all reasonable people at the time. So what have I essentially come to myself in looking at this and thinking about it? Well, I've come to the conclusion that the so-called war between science and religion really ought to be viewed as a conflict within religion over how to view science. It's about essentially how to grapple with, how religions can grapple with discoveries about the material world. Science can go on sort of doing its own thing quite happily without any particular religion or indeed any religion at all being true. But I think all religions really need to honestly grapple with the things that scientists can discover about the nature of the material world. And the conversation that we're having essentially in the public today really is not doing that at a level that I think that the history of it sort of deserves. And I think that modern young Earth creationists, and I want to modify that with young Earth creationists, abandon faith that what we can learn from the study of nature. In other words, they've sort of turned their back on what we can learn from God's other book, and selectively cherry-picking data to support a case does not honor the data. So where does this all leave us? Why is this important? Well, I would argue to you that this century that we're at now, the 21st century, is an incredibly pivotal point in the history of humanity. We have some really big problems confronting us about the nature of the world, our place in it, our stewardship of the planet. We're facing crises in water, soil, energy, the atmosphere in terms of climate, all of which may come to a head later this century. And frankly, I think it's actually really counterproductive as a species for us to spend a lot of time debating arguments that were essentially settled a couple hundred years ago. What does this mean essentially, in my view, for the nature and the power of the story of Noah's flood? Oh, I think it is a very powerful story. I think it's a very intriguing story. I think it may very well have its roots in real events. But I think that the modern sort of value of the story may lie much more in its nature as a teaching device about the responsibility that humanity has to care for creation. And actually carry forward all that is with us on this planet into the foreseeable future through the kinds of crises that we actually face in the coming decades. And I think if we view the story of Noah's flood through that lens, it actually still reads as a very powerful and very spiritual story in terms of the nature of humanity and our relationship to the world. Now, people have always essentially used the filter of faith and the lens of reason to try and make sense of our place in the world. And I think that the story of Noah's flood is a very interesting historical example of how we can think through that and how we can look at the way that religious stories have actually helped shape the evolution and development of science, and how theology has actually responded and evolved in response to that, to those kinds of discoveries. And I'll leave the story of Noah's flood there with you. I'll obviously recommend the book, The Rocks. You don't write a book if you don't want people to read it, so I obviously recommend that everybody reads it. It's intended to make you, think for yourself, argue with it if you want. But the important part is to think about it and to think for yourself. The previous books I've written are Dirt, the Erosion of Civilizations, about the history of farming, and King of Fish, the 1,000-Year Run of Salmon, about the history of salmon management in England, New England, and the Northwest where I live. There are stories about how people interact with nature and how economic systems can interact with natural systems in ways that don't always lead to outcomes we desire. And the most recent one is coming out in November, called The Hidden Half of Nature, The Microbial Roots of Life and Health, that I wrote with my wife. She's a biologist, and we've become utterly fascinated with the way that the recent discoveries in the last decade or two, and it seems now every week in Science and Nature, are revealing new ways that microbial life is influencing the macroscopic life that we know, and how foundational that is to the practice of agriculture and medicine, and how wrong we've gotten some elements of that because we have not fully appreciated the role microbial life plays. So thank you very much for the invitation. I look forward to chatting with anybody at the reception afterwards, and thank you much.